Hello YouTube, it's Akash with another episode on physics. We'll be discussing laws of motion and solving the AIIMS VERMA questions. So our topic today will be the question number 27 of laws of motion. In figure 5A11, M1 is 5 kg, M2 is 2 kg, force 1 Newton is acting on both the masses. Find the acceleration of either block. Discuss the motion of block M1 if string breaks but F continues to act. You can see a pulley over which a string passes and two masses M1 and M2 are hanging from there, and a force of F 1 Newton is acting on both the masses. So how do we approach such questions? As I have already mentioned, we'll first quickly draw the free body diagram for both the masses. So let us draw the free body diagram of mass 1 is M1 and another of mass M2. So we can appreciate that M2 is having a force downward of F and a mass. So a gravitational force will also act in it. Equally, M1 will have a force F plus M1G acting downward. But we have to understand in both these cases there is a tension T acting upward as it is a single string. So this T will be added in upward direction. And let us assume the whole system has an acceleration because M1 is more, so we'll assume it to this way, and you can easily appreciate if acceleration comes negative, it will be in opposite direction. So whole system has an acceleration this way, anti-clockwise, okay? So yes, M1 is having an acceleration this way, and M2 is having an acceleration this way. So we can easily write the equations, laws of motion. So we can, but you have to understand we have got the easiest tricks out there. So we'll use our tricks to solve it easily. So our trick is external force. For getting the acceleration, you have to understand external force. External force is equal to total mass into acceleration. So without the free body diagram we can solve it. How we can see? So our external force is nothing but see F acting on the both these things. So it will cancel each other. Two forces acting in opposite directions will cancel each other. Equal force, so they'll cancel each other. Ultimate force acting downward will be M1G minus M2G. You can see it easily. The force acting downward is M1G, M2G. Okay. So total force acting downward is M1G minus M2G. We'll write external force is M1G minus M2G. We can actually write it in bracket that plus F minus F, and both of these cancel each other, so we have not written these things. It is equal to total mass. So total mass is M1 plus M2, and the acceleration is A. So we have written the equation, so we can easily get the values of A from it, and A is nothing other than M1 minus M2 G by M1 plus M2. So I've got the value of acceleration. Okay. And putting the values of M1, M2 and G, you can get, this is nothing other than 5 minus 2 by 5 plus 2 into 10. So its value is equal to 30 plus 7. 330 by 30 by 7. So its value is 30 by 7. We've easily got the value of the acceleration. So our first part is done. Find the acceleration. We have found out the acceleration. What is the value? We've written it. Acceleration is equal to this term. So we have used the tricks to solve it, but we can also write the equations of laws of motion. From here it would have been F plus M1G minus T is equal to M1A, and from the second mass we have to write T minus F minus M2G is equal to M2A. So these would have been the two equations. But you have to understand, you have to find the value of the T to see the effects, actually, to see the effects, or rather we can understand it like this. If we have to find the value of T, we have to use the laws of motions, or rather we can follow this trick that external force is equal to total mass into acceleration. So such we can get the acceleration. But for tension you have to go through a normal procedure of free body diagram. Now we have to understand how we'll be able to get the motion of the block M1 if the string breaks and F continues to X. So we'll see that when string breaks. Now let us assume the string breaks. Okay. So actually that is the tension, it becomes 0. But we know that it has got the acceleration, and again two forces are actually acting on it. Two forces are equally acting on it. but tension is equal to 0. So this is the free body diagram of this thing. We'll draw it again. See, it is M1. It is having a gravity G downward, so it will have the force M1G downward plus force F. Since tension is 0, so we will not know the tension, but it have got an acceleration A downward. Okay. But let us assume it is A dash because it is an EUA, because due to these forces only, since tension is equal to 0. So I will write the equation in this way. M1A is equal to total force acting on this system, M1G plus F, since F is not now being cancelled because the system is separate from the previous system. This is only a single system that we are talking. So this is the equation, so we can easily find the acceleration for this when the string is cut. So I write A dash, so A dash is equal to M1G plus F and by divided by M1. So this is the answer for the second, and its value is equal to 5 into 10 plus 1 divided by 5. So it is 51 by 5. What we have, hope you like the video, share the video, subscribe the channel NEET, the Akash videos, and press the bell icon to get notifications instant.